Okay, this is the third video of graphing sine and cosine parent graphs. I've got the 4.5 of sine and cosine functions packet next to me right now. So if you could go to page 3 where you see this equation, y equals 3 sine 4x. So we've talked about amplitude and we've talked about period, but we have not talked about how you can find them by looking at the equation of the sine and cosine graph. Well, the amplitude is always telling you your height of your wave. So the amplitude is always a scale change. So think about a scale change. That's that number 3 that's before the word sine. So your amplitude for this height is 3. So instead of it going up from 0 to 1, like from the baseline on the parent graphs, we're now going to go from 0 to 3 to get to our crest and 0 to negative 3 to get to our trough. Well, you see this 4, that 4x. Well, that affects your period. So the easiest way to figure out what the real period is of your graph is you take that 4x and you set it equal to what a real period is, which is 2 pi. Then what you do is you solve for x, like we do in algebra. So when we solve for x, we divide by 4. We get x equals 2 pi over 4, which is just pi over 2. So now that means this wave is a quick wave because it means it reaches one whole cycle in 90 degrees. Okay? How do you graph this? Well, you could take your sine parent points and make a table. So here's 0. Actually, that's not 0. Hold on. Here's our x, and then here's our sine x for what we're talking about for our graph. And if you remember, I talked about the last video, is you have your 5 main points that you always choose for sine. Start at 0, and you end at 2 pi. And then think about it. What's halfway is pi. What's halfway between 0 and pi is pi over 2. What's halfway between pi and 2 pi? It's 1.5 pi, but we call it 3 pi over 2. Remember, sine is looking at the y values of the unit circle. This x right here in sine x is not talking about the x coordinate in the unit circle, it's just talking about what sine is in general. Okay? And so when we know sine at 0 degrees, that's 0. At pi over 2, that's when we are at 1. At pi, we're back at 0. At 3 pi over 2, we're at negative 1. And at 2 pi, we're back to 0. And then what you could do, if you really wanted to do this, is you could just do your transformations on what we know about transformations. Think about that 3. That's outside. That means it's affecting here. Okay? Think about that 4x. Normally we would say you'd multiply by the inverse, so you multiply both sides by 1/4. And then that's where you get all these answers. So this becomes 0, this becomes 3, this becomes 0, this becomes negative 3, and this becomes 0. Then over here, when you multiply by 1/4, you have 0, then you have pi over 8, then you have pi over 4, then you have 3 pi over 8, and then you have 2 pi over 4, which is pi over 2. And sure enough, you can see that that's the period, which is pi over 2. Okay? Okay, so let's graph this. Now, I did that table just to show you how to do it with table, and you can still use tables if you want to use tables, but I found that it's a lot easier just to think about that the period is pi over 2, and the amplitude, which is your height, is 3. And your shape of sine never changes. It's just dependent on what happens on how quick it is or how low it is. So we know right here the baseline is what our x-axis is. We know the highest we're going to go to is 3, and the lowest we go to is negative 3. So just mark somewhere halfway between 0, 3, and 0, and negative 3. And I know that I start at 0 right here for my angle, and I know I'm going to end way out over here at pi over 2. Now, I told you have 5 main points that you always plot, including 0. So think about this. This is a little bit about fractions. I start at 0, I end at pi over 2. So then go, who's halfway, which is this mark right here? Well, what's half of a half? It's a fourth. So I'm at pi over 4. Now you're between 0 and pi over 4. What's half of a fourth? You're at pi over 8. Okay? So then you're missing this one kind of right here in the in between pi over 4 and pi over 8. If you're like, oh, I have no idea what that is, think about this. This first mark right here, this pi over 8, tells you what your scale is, your increments. So this is called 1 pi over 8. This is 2 pi over 8. So this one that's missing must be 3 pi over 8. And then this is 4 pi over 8. You're always welcome to always leave it in what the scale is. You don't have to leave it in reduced form. Now remember, what is sine start? Where does sine always start at? On the unit circle, it always starts at 0. I told you, remember, the shape never changes. So if you look at your video for the very first video, remember, sine starts at 0. Then up at pi over 8, it's at the it's what we call the max or the crest. At pi over 4, we're at the baseline. At 3 pi over 8, we're at -3, which is the trough. And then back at pi over 2, we are back here at the baseline. And sure enough, you've got the sine graph looking exactly the same. It's just that now the period is, sorry, that should say pi over 2, not pi over 3 over there. That's my mistake. The period is at pi over 2. The amplitude is 3. What's your domain? It's still going to be -infinity to infinity, because it always is. What's your range? It's from -3 to 3. Okay? And that's it.